Okay, so in yesterday's video, we were looking at Tinkerbell going on her adventure or her obstacle course. And in yesterday's video, she didn't really have a choice in what she wanted to do. So she left the pixie dust tree, then she went onto the river, she fought the ladybug, then she had to go through the log, and then she had to go up the tree before she could go back home. Okay, now today we are going to look at what happens when there's a junction in the path. And that's the little part that we skipped over yesterday. And it said that the different paths of a junction will use the same amount of pixie dust irrespective of how difficult it is. So let's go and see if it actually makes sense to you. In one of the questions in yesterday's quiz, it said that right before she entered the mystery obstacle, Tinkerbell had 15 joules. If she has 12 joules left before she has to cross the bridge, how many joules did the mystery obstacle use? Okay, so let's just put some numbers in here. And please always put some numbers on the paper. It makes it so much easier for your brain to follow your reasoning. So it says that right before this mystery obstacle, she had 15 joules. Okay, and right after, just before she has to cross the bridge, she has 12 joules left, right? So it should make sense that she had to use 3 joules during this mystery obstacle. Okay, so whatever happens or happened underneath this question mark, she used 3 joules. All right, now let's zoom in and we take this question mark away. And now we see today she has a choice. So she can either go rock climbing or she can go to the skate park. Okay, so let's just follow Tinkerbell's journey and make sure that we know what's going on. So she leaves the pixie dust tree with a certain amount of pixie dust. Then she goes onto the river where she uses some pixie dust. And here she has a choice, only one choice. She can either go rock climbing or she can go and do skateboarding. But whatever obstacle she chooses, she will use 3 joules. Okay, and then when she comes out the other side, on the other side of the junction, she will have a certain amount of pixie dust left, and she has to use all of them to go onto the bridge. Okay, so if you haven't written it down yet, please write it down. The different paths of a junction will use the same amount of pixie dust irrespective of how difficult it is. And just like yesterday, we're going to swap it over into science speak. So the different paths, it's not of a junction, it's a parallel circuit. And we're going to look at it now. Will use the same amount of electric energy. That's your W, irrespective of how difficult it is. So it's irrespective of the resistance. The symbol for resistance, if you want to write it down so long, is R. And it's measured in ohm, OHM. The symbol therefore is that little squiggle thing. But we'll get to that. Okay, so the different parts of a parallel circuit will use the same amount of energy irrespective of the resistance of that path. So now I want to go back to our pixie dust tree story and I'm going to swap it over to a circuit. Okay, so here is our story about Tinkerbell going on her adventure, and then we are going to swap the elements of our story with science. So the tree we swap with a battery, and then our obstacles, obstacle 1, obstacle 2 if you see it as a unit, and obstacle 3 we swap with obstacle 1, obstacle 2 and obstacle 3, but in obstacle 2 we have a choice. We have a parallel circuit. Okay, and if we just quickly go and look what an electron will do, the electron will leave the battery from the small side, and when it leaves the battery it will have some energy, let's say carrying it on its back. It will go through the connective wire and it will go through the first resistor where it will use, let's use 10 again. So we start with 10 joules. Here we use, let's say, 3 joules. Out the other side we have 7 joules left. And now the electron will choose. It will either go through resistor 2A or it will go through resistor 2B. But whatever route it takes, it's going to use, let's say, 2 joules. Okay, so 2 joules through the top or 2 joules through the bottom. So when it comes out resistor number 2, whichever path it took, it will have 5 joules left, which means all 5 of those last joules need to be used going through resistor 3. Okay, so we start with 10. After resistor 1, we have 7 joules left. After resistor 2, we have 5 joules left. And then when the electron comes out, the last resistor, it has 0 joules left. Okay, and then it will go back to the battery to recharge itself, in a sense, and then the circuit will start again. And then next time around, let's say for the first round, it went through to A. The next round, it might go through to B. We don't know, okay? And because we don't know, it sort of makes sense that it will always use the same amount of energy, so that this little sum of ours works out, okay? And then we're going on to part 3. So if you just want to make sure you have the right wording for part 3. So parallel paths in a circuit will use the same amount of energy irrespective of its resistance. Okay, so that's that for this video. You can go back to the quiz and just make sure you understand the parallel paths or the junction in the obstacle course. And then we will go on to the teams participating in this race.